Good morning, students. Today we are going to see the another subtopic, the hydrological cycle, global ozone circulation, and El Nino and its effect, so and as well as solar radiation. Okay, these subtopics is very important to understand the climate pattern. This lecture is going to explore how water movement, ocean circulation, and solar energy interact to shape Earth climate. We also going to cover the hydrological cycle, global ocean circulation, the ENSO phenomena, which we have already seen, but we are going to touch upon that one again, and the role of solar radiation. The focus will be on process, mechanism, and their climatic impacts at both regional and global scales. Earth's climate system is powered by the constant exchange of water and energy. Underline the word constant exchange of water and energy between oceans, atmosphere, and land. So it is an exchange of water and the energy between the oceans, atmosphere, and land. The hydrological cycle moves water through evaporation, condensation, precipitation, and runoff, redistributing the heat in the process. So, what is hydrological cycle? It's a movement of water. Okay, through evaporation. When the sun radiation comes and hit the ocean water will get evaporated. Okay, what is condensation? Condensation in the sense this water droplets will try to condense and then precipitate as a rainfall. Okay, so and runoff is a water which has been through rainfall when it passes to the land is a runoff, or infiltration, what you say, which has been getting into the earth's surface. Okay, to increase the level underneath the um, level of water, underneath water level. Okay, so redistribution heat in the process. So this hydrological cycle redistribute the heat in the process. Ocean circulation redistributes thermal energy across the globe, influencing regional climates. Solar radiation is the ultimate energy source driving all atmospheric and ozonic process. From where the heat energy comes? The heat energy comes from the solar radiation, which is the ultimate energy source. If the sun is not there, then imagine what will happen. All this process stops. The hydrological cycle definition goes like this. The hydrological cycle is the continuous movement of water between the Earth's surface, atmosphere, and oceans. It's a movement of water between the Earth's surface, atmosphere, and oceans. Okay, so it operates through interconnected process like evaporation, condensation, precipitation, infiltration. Just now I told you infiltration, runoff, and re-evaporation. This cycle maintains the distribution. What is re-evaporation? Re-evaporation means after it comes down, again it gets heated up and go at the top. Okay. This cycle maintains the distribution of fresh water resources and regulates the climate by moving the latent heat. So what is latent heat? Latent heat is the amount of heat energy, okay, which has been utilized to change in phase from water to get evaporated. Okay. So that's the thing. Components of hydrological cycle. So the components can be divided into, as I told you, evaporation, condensation, precipitation, runoff, and infiltration. They have given the definition on each and everything. Okay, we can quickly go and go through it. Evaporation is a conversion of water from liquid to vapor, primarily from oceans. What is condensation? Formation of clouds. Okay, when vapor cools and changes to liquid, changes to liquid, condensation. Precipitation, water falling back to earth as rain, snow, sleet, or hail. Okay, so please guys, rain, snow, you know what is hail, what is sleet, just go and refer. Runoff, water movement over land into rivers, lakes, and seas. So runoff in the sense, so which has been going to a river or lake or seas. Okay, so infiltration, that is a estuaries. Estuaries is a thing which has been connected the river and the sea is called, region is called estuaries. Just go and see. Okay, so the infiltration, water soaking into the ground to form groundwater reserves, as I told you. So these are all definition I already told you. Okay, I will go for the next slide. That is ocean versus continental water balance. Continents generally receive more precipitation than evaporation. Okay, so that means they will get a more rainfall when compared to the getting evaporated, creating river systems. Okay, ozones experience more evaporation than precipitation. When ozones experience more evaporation than when compared to the precipitation in the ocean. So, do you think actually on the ocean there will be rainfall? Definitely there will be rainfall, but it's not comparatively low when compared to the land. Okay, serving as a primary vapor sources. Okay, so vapor sources in the sense is getting vaporized and then go at the top and then again coming back as a condensation, okay, and then precipitation and again evaporation. Okay, so this imbalance is balanced by the moisture transport via winds from ocean to land. Global water storage. The atmosphere holds a tiny fraction, that is a 0.001% of Earth total water as water. Just imagine Earth total water of 0.001 is not small, okay, still large, right? So it also vapor condense. If all vapor condensed, it could cover the globe with only 3 centimeter of rain. Just imagine. Okay, 3 centimeter of rain. This throughout the globe, when the air moisture in the air is condensed and it become a dry air. Okay, when it falls on the globe, it will have a 3 centimeter of rain. Approximately, there is only a 3 centimeter of rain. Okay, 3 centimeter of rain through the globe is not a small quantity. That's what I mean. Okay, oceans, glaciers, and groundwater hold the largest reservoirs of water. Ozone, glaciers, and groundwater hold the largest reservoirs of water. Annually, 434 into 10 power 10 liters of vapor move from ocean to atmosphere. From the ocean to atmosphere, how much air is getting evaporated? 434 into 10 power 10 liters of vapor move from ocean to the amount of liters of vapor is moving. Okay, of this, 398 units return to the ocean via precipitation. Over land, 107 units fall as precipitation. Approximately 71 units re-evaporate and 36 units return to the ocean as runoff. Okay, so they have used a literature review as statistics, water movement statistics, and a long distance vapor transport. Water evaporated in one location may precipitate those thousands of kilometers away. Wind patterns enable this global interconnectivity, making local water cycle dependent on distant sources. Example, moisture from the Indian Ocean feeding rainfall in Africa. So the moisture from the Indian Ocean feeding rainfall in the Africa. It's not a long distance vapor transport. Just imagine. Okay, so actually, I would like to say the people who have been doing what you call mm, therapy, right? I mean, the muscles and things like that. Once the muscles get sprained, they will turn over the thing on the other side. Okay, meaning to say, some pain will be somewhere, and they will find out the root cause somewhere of the body. Okay, something like that. Okay, what I'm trying to say is that the moisture in the Indian Ocean feeding rainfall in the rainfall Africa. Okay, so it's all interconnected. That's what I told. So it's not only one country need to take a decision on the things. Okay, regarding the global climate. Okay, the global climate is depend on not one region. It depends on the overall strategy. Okay, the oceans can act as a heat and water buffers, storing energy and redistributing it slowly over time. Ocean currents move warm water from equator to poles. So we have seen the cold ocean current and warm ocean current in the very extensively in the previous classes. Ocean currents move warm water from equator to poles and cold water from poles to equator. These currents shape coastal climate and influence the weather patterns globally. Okay, so the coastal climate depends on the ocean currents. Okay, that you need to understood. And ocean's role in climate models. Okay, climate models show global temperature patterns can be reproduced using only sea surface temperature. Sea surface temperature is very very important. When it is very hot or when it is very cold, the wind pattern will change. This highlights the ozones as a primary driver in the climate system. Accurate predictions require fully coupled ozone atmosphere models. Accurate prediction require fully coupled ozone atmosphere models. Okay, ozone general circulation model. Ozone general circulation models simulate ocean currents, energy transport, and temperature changes. They often require flux correction to prevent unrealistic model drift. They are essential for long-term climate projections. And heat transport by oceans. Ozones prevent poles from becoming extremely cold and tropics from overheating. Meridional heat transport. Okay, very important thing. Meridional heat transport peaks at 40 to 50 degree latitude in both hemispheres. So you should know what is meridional heat transfer. Meridional heat transfer refers to the process of heat moving from the equator toward the poles in both the atmosphere and the ocean. This transfer is essential for maintaining Earth climate by regulating temperature differences between high and low latitudes. The atmosphere and ocean work together to transport heat, with the atmosphere playing a dominant role overall, but the ozone contribution is particularly significant at lower latitudes. Key aspects of meridional heat transfer: driving force, atmospheric transport, ozonic transport, and balance and stability. We'll see one by one. Driving force: the primary driving force is the temperature difference between the equator and the poles. The equator receives more solar radiation than it emits, while the poles lose more energy than they receive. Atmospheric transport: the atmosphere moves heat through various mechanisms, including wind patterns, atmospheric rivers, and convection. Evaporation and condensation also plays a crucial role, with evaporating adding moisture and heat to the atmosphere, and condensation releasing heat. Ozonic transport: the ozonic circulation, particularly meridional overturning circulation, plays a significant role in heat transport, especially in the Atlantic Ocean. The meridional overturning circulation involves the movement of warm surface and intermediate waters northward and southward movement of deeper and colder waters. Balance and stability: the meridional heat transport helps balance the energy budget on Earth, ensuring that the tropics don't become excessively hot and polar regions don't become excessively cold. So, in a short term, meridional heat transfer refers to the process of heat moving from the equator towards the poles in both the atmosphere and the ozone. Okay, that's what the meridional heat transport means. So the meridional heat transport peaks at 40 to 50-degree latitude in both hemispheres. Now southern hemisphere transport is slightly greater due to ozonic experience. So in the ENSO events, we have seen El Nino and La Nino and neutral. Again, we will quickly go through this one. ENSO is the strongest natural climate fluctuation recurring every 2 to 7 years. It is a coupled ozone atmosphere system in the tropical Pacific. ENSO phases El Nino and La Nino. One is warm phase and another one is cold phase. Cool phase. And southern oscillation, and atmospheric pressure fluctuation measured by the southern oscillation index. What is a southern oscillation index? So it has been again divided into negative southern oscillation index and positive southern oscillation index. For negative socks is a nothing but is a El Nino condition. Positive southern oscillation index is a La Nino condition. So one is weakened the trade wind, another one is a stronger trade wind that we have seen actually the El Nino conditions. Okay, also linked to the Walker circulation across the Pacific. Walker circulation: trade winds carry moisture westward, fueling monsoon rains over Asia and Australia. Air rises over warm waters, flows eastward in the upper atmosphere and sink over the eastern Pacific. Disruption of this loop marks INSO events. Underline the word disruption of this loop marks INSO events. Okay, so El Nino condition: trade winds weaken, warm waters shift eastward, convection and rainfall shift to central or eastern Pacific, upwelling of Peru decreases, warming surface waters further global rainfall patterns are disrupted because of El Nino conditions. La Nino conditions, opposite of El Nino condition: trade wind strengthen, cooler SST. Such SST which have seen cooler SSTs dominate Central Eastern Pacific. Okay, rainfall remains concentrated over Asia and Australia. Enhanced upwelling increases nutrient-rich waters of South America. Inciso global impact alters tropical rainfall pattern in Indian Ocean, Africa, and South America. So it will alter the tropical rainfall pattern. And so events El Nino, La Nino, or neutral will affect the tropical patterns in Indian Ocean, Africa, and South America, generate waves in jet streams, shifting storm tracks, can cause drought, flood, or altered monsoon patterns globally. So underline the word can cause drought, flood, or altered monsoon. Okay, because of this, these are the impact of the ensues events that La Nino and El Nino effect. Okay, weaken trade winds or strengthen trade winds and so on and so forth. Okay, so ENSO and India strong El Nino events often weaken Indian monsoon rainfall. La Nino can strengthen monsoon activity. ENSO monitoring helps predict seasonal agriculture impact. Solar radiation role in climate. Sun is the primary energy source for Earth climate system. That's why I told. Okay, without sun, the wind pattern will not go because there won't be energy heat transfer. Okay, so that it's not get heated up. So the movement of ocean current will not take place, and because of the get heated up, the hot air will not go at the top, and then there won't be any pressure creation between the regions. Obviously there won't be flow of air. Yeah, okay, this is all disrupted. Okay, sun is the primary energy source for earth climate system, drives evaporation, atmospheric circulation and ozone currents. Energy transport occurs via radiation across space. What is atmospheric absorption? Ozone absorbs harmful UV radiation. Okay, so the ozone is a very important thing which will absorb the UV radiation. If there is no, because there is no ozone, all the light will pass through the ozone layer. I mean, if there is no ozone layer, obviously it will pass through the Earth atmosphere and then enters into the Earth atmosphere, and then obviously it will affect the things. Okay, that means that it will cause a cancer and so on and so forth. Okay, so ozone absorbs harmful UV radiation, water vapor absorbs much infrared radiation. So these are the things which are acting as a protection. So there you might have heard about ozone depletion because of CF2Cl2, dichlorofluorocarbon, that is freon, which has been used previously in refrigeration and all the cooling agents. I mean, where the cooling is secured, liquid ammonia has been replaced right now. Okay, so when this CF2Cl2 has been used, it will continuously break down the ozone molecules into oxygen. Okay, and the chlorine, chlorine radical. Okay, so that you might have studied during your environmental engineering course or even in school days nowadays. Okay, so ozone depletion, you know the effect of it. I don't want to touch upon here. Okay, just try to understand what is a ozone advantages, and then what is the advantage of having a water vapor in the air, absorbs much infrared radiation. Carbon dioxide absorbs specific infrared bands, contributing to greenhouse effect. Atmospheric window allows infrared escape between 8 to 2 micrometer. And the roles of clouds. Clouds absorb and re-radiate heat, especially at night. They also reflect incoming solar radiation, albedo effect. Cumulonimbus clouds can reflect over 90% of sunlight. Cumulonimbus means is a very vertical cloud, denser cloud, and it has a thunderstorm effect. Okay, that's what we have seen in the last lecture. Okay, so albedo surface reflectivity. Earth average albedo is 36%. Snow and ice have high albedo. Ozones have very low albedo. Albedo influences surface heating and local climates. Scattering of radiation. Shorter wavelengths scatter more, giving the sky is blue color, and larger particles scatter all wavelengths equally, appearing white. Scattering reduces direct solar energy reaching the surface. Latitude solar energy distribution. Tropics receive 2.5 times more solar energy than poles annually. High latitudes receive weaker sunlight due to lower sun angles. Okay, let's say you have a higher altitude, receive weaker sunlight due to lower sun angle. Okay, so because of that, the high altitudes are not getting much sunlight, lower sun angles. Okay, receive weaker sunlight due to lower sun. So if you go for Ooty, Kodaikanal, you don't find a much high. Okay, and also it will, the pressure is very less there. Obviously the wind will flow very with higher concentration. Okay, that means with high intensity. Okay, this imbalance drives global wind and ozone circulation. What they mean is that because this okay, latitudinal solar energy distribution imbalance in heat drives global wind and ozone circulation. So yeah, as we know, 23.5 degree tilt causes seasonal shift in solar energy distribution. Tropics experience overhead sun once a year. Polar regions have continuous daylight or darkness for months. Polar regions have continuous daylight or darkness for months. So if you go to Scotland, okay, you could able to see the sunlight until night. One of my friends, she's working there. Okay, she used to show to me at 8 o'clock or 9 o'clock. It looks like evening 4 or 5. How it looks like. Okay, so midnight, or I mean night, even midnight also it looks like. So there are my few friends who are residing in the northern side, in the Atlantic, I mean, of the polar region. Okay, they used to say when they go for fasting during fasting period until it became dawn, then they could not stop the fasting, right? Especially the our Hindu friends. Okay, so they will find it very difficult, and the 13 to 14 hours they need to do fasting because they will become dark only at late night. Okay, so but in India you become it become what called become night usually at 6 or 6:30 or around 6:45, right? So the polar regions have continuous daylight and darkness for months. Just imagine. Okay, and polar versus tropical energy balance. Regions poleward of 40° lose more radiation than they gain. Regions poleward of 40° lose more radiation than they gain. Regions equator of 40° have a net surplus heat transport by atmosphere. That means poleward means poleward, equator word. Okay, that means very regions poleward of 40° for regions equator of 40° have a net surplus, lose more radiation. Okay, so they will get a more surplus equator region, poleward will have a less radiation. That's what they mean. Heat transport by atmosphere and ozone balances these differences. Radiation balance. Global average radiation budget incoming is equal to outgoing. Radiation balance. Global average radiation budget incoming is equal to outgoing. Local imbalance drives circulation. Without energy redistribution, poles would freeze and tropics overheat. Okay, without energy redistribution. So when there is no energy distribution, obviously it will freeze. One region will freeze, another one we will find it very very hot because of this angle of tilting and because of the energy distribution among between the places. Okay, we are safe to live in this planet. Climate system interconnection, hydrological cycle, ocean currents, ENSO, and solar input are interconnected. Hydrological cycle, how the water has been recycling inside the atmosphere. Okay, ocean currents, how the warm water getting heated up and then moves to the towards the polar region, and cold water from there moves again to the equator. Okay, ENSO events, El Nino events, and La Nino events. One weaken the trade wind and one strengthen the trade wind, and solar input are interconnected. Disturbance in one element can cascade through the climate system. So when you try to disturb one thing, obviously it will affect the cascade, the other cascade effect could be able to see seen on the climate change, climate system. Example, ENSO altering global precipitation and temperature pattern, altering the global precipitation, the rainfall, and also the temperature pattern. Sometimes it may you will get a flood, sometimes you will get a what we call drought. And summary, what you need to take away from here is that it is all interconnected. Okay, water movement and solar energy are the twin engines of the Earth climate. So the movement of water and the solar energy are very important. That will reach the Earth climate. Ozone store and transport heat. The atmosphere distribute water and energy. Solar radiation uneven distribution drives wind current and season. Solar radiation uneven distribution drives the wind currents, ozone currents, and seasons. Understanding this process is a key to predict and adapting to the climate variability. Okay, so the sun radiation and the hydrological cycle, the ocean current are interconnected. As I told you, is interconnected. Okay, hydrological cycle, ozone current, sun, and solar input. For example, when me motor, or what you call it, when engine need to work, it need to all the parts need to be properly work, and it's supposed to be because of the interconnection of all the parts. Obviously the car can move. Similarly, for the good condition, I mean what you call it, if it is properly connected, you will get a rainfall in a monsoon, and what you call some summer, and things like that. This will keep on having a same pattern. If anthropogenic activities happen, obviously it will alter the cycle. It will be very difficult actually to withstand, I mean to sustain in that particular changes in environment condition, that is especially the climate. If it is very drought, what will happen? Because of the this all happen because of the disturbing the natural pattern. Okay, so with this note, I just try to stop this lecture. We will see in next lecture shortly. Hope you understood and gain an experience, gain a knowledge on what has been taught today. Okay, with this note, I stop it here. Thank you.